Hey everybody, I hope all is going great. Today we're going to be talking about 7.4. We're going to be showing that triangles are similar using the, oh, would you look at that? I think we're familiar with these. Okay, so we are going to be showing two triangles that are similar using the SSS or side-side-side theorem or the SAS side angle side theorem. Okay, let's check out. We might have a couple of proofs. Oh, sorry, a couple of theorems to write. So the very first one being the side-side-side similarity theorem. Pause now, and I will explain. All right, so when you look at this, if three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So if you look at A, B, and D, E, notice they are in red. So if those are going to be proportional, and then B, C, and E, F are proportional. And then you look at AE and DF. If all three of those sides are going to be proportional to the corresponding side of the other triangle, then they are going to be similar. Notice now we have side angle side similarity. Try this one. All right. So now when we look at this one, the key is to have the included angle. Okay, you need that included angle. And remember, an included angle happens when two segments form together at one point. Okay, so if you look at AB and BC, they form together at angle B. Same thing with DE and EF. They form at angle E. So when we look at this, we have AB and BC are they are going to be proportional to DE and EF, and then angle B is congruent to angle E. That's very important. That included angle is going to be congruent. Awesome. All right, so now we're going to look at this type of a problem. When it says determine whether the triangles are similar. If they are similar, write a similarity statement and then explain your reasoning. Your explanation is going to be your postulate, or sorry, your theorem that we know is true. Okay, so when we look at this, can we prove these triangles are similar? Well, first we have to look at the information we are given. Okay, the very first one is going to be, well, we know that angle D is going to be congruent to angle H. How do we know that? Well, they're both 70 degrees, so they have to be congruent to one another. All right, so we know that piece of information. Okay, what else do we know? Well, we're going to have to look at the ratios or the scale factors of the corresponding sides. So I'm going to look at the two longest sides here. Okay, that being DF and HK. Okay, so if I look at DF and HK, those are the two longest sides going across here. So I'm going to put those one over the other. I'm going to put 5.8 then over 2.9. And when I simplify this down, remember we have to get into simplest form, we get a scale factor of 2 over 1. All right, so the scale factor of DF over HK is 2 over 1. In other words, this first triangle here is 2 times the size of that second triangle, according to this first ratio. But we have to double check with our second ratio. And that second ratio, again, we're going to put the larger triangle on top, being DE, because that's the segment we know, over the corresponding side on the other side, which is JH. Okay, we know that that is going to be 2 over 1. Uh-oh, notice what do we have here? What do we have here? They're the exact same scale factor. Okay, so are they proportional to one another? Yes, they are. So we have two sides, two corresponding sides that are proportionate to one another. and we have the included angle that is congruent to each other. So what do we know? Well, we know that, again, we're looking for our similarity statement. We know that triangle DEF is going to be similar to triangle HJK. And how do we know that? Well, because of the side angle side similarity theorem. Make sure that you write down similarity. Okay, again, because we know side angle side, that we know of the congruence theorem, but we also need to know in this problem that they're not congruent, they're similar. Okay, so be careful there. So very first thing you have to do is you have to identify the given information. Then we identified the given information of angle D being congruent to angle H. Then we focused on the sides. Okay, we checked to see if they were proportionate to one another. We noticed they were proportionate to one another. They had the exact same scale factor, so we could write out our similarity statement based on the SAS similarity theorem. All right, next. All right, so now if you look at this, what I want you to do is, it says verify triangle TXU is going to be similar to triangle VXW. So give this one a shot. See if you can verify. Then give me a reason as to how you verified it. All right? Give it a shot. All right. The very first, when looking at this, the very first thing I would do is I would identify if there's any congruent angles. Are there any congruent angles? Yeah, there are. If you look at angle TXU. TXU, Texas University. TXU? Is that okay? Maybe not. All right. And then angle WXU. Okay. These two angles right here are congruent. Why are they congruent? Vertical angles. Yeah, vertical angles. Man, you guys are good. Okay. Vertical angles tells me that those two angles are congruent. Now, what I have to do is I have to see if they are proportional. And how do I do that? Is I check their sides. Now, when I look at the sides, I am always going to be putting the larger sides over the top of each other and then kind of moving it down. So, I'm going to start off with UX. I'm going to put UX over WX. And the reason behind that is this is my longer side on the smaller triangle and my longest side on the larger triangle. So if I look at that, I'm going to put 15 over 20. What is my scale factor? It is going to be 3/4. 3/4. I can divide by 5 and I get 3/4. All right. Next piece of information, I need to check the other two. See if that answer equals 3/4. So I'm going to look at TU and TX and VX. So which one goes on top? Okay. Why? All right. It just kind of sounds weird asking and talking to myself. Okay. But if you look at this, we need to put TX on top. And the reason behind that is we used that triangle on top, the smaller triangle on top, on the first ratio, which means we have to do the exact same thing on the second ratio. Okay, so notice I put short triangle on over tall triangle. Okay, I use that same exact idea for both ratios, and I need to. So, which means I now have 12 over 16. And I could simplify this down, divide each one by 4, and I get 3/4. Oh, my goodness, look at that. They are the exact same. What does that mean now? What does that mean? Well, that means that triangle TXU is going to be similar to triangle VXW. Why? Because of the side angle side similarity theorem. Okay, side, angle, side, similarity theorem. We have two sides. Bam, bam. And we have the included angle, which is bam. That is going to be, the two sides are proportional to the other two sides. Bam, bam. And the included angles are congruent. Whammo. Oh my goodness. Sounds weird. All right. Next and last. Here is the last slide I have for you today. Notice it says determine whether the triangles are similar. If they are similar, write a similarity statement. All right, so let's check this one out. All right. Again, I use the greatest sides on each one. I start with the longest sides, and then I kind of move down. All right, so give the first one a shot, or give this one a shot. All right, so the very first one, again, I start with the longest side. So my longest side of triangle A is 24. My longest side of triangle B is 6. So that means I have 24 over 6. Okay, what is the scale factor on that? 4 over 1, because I can divide each one by 6. Okay, so that's my very first one. How about the second one? Okay, I'm going to go on and I'm going to try the medium angles. Or sorry, medium sides, which is 12 over 5 is equal to, can we simplify that down? No, you can't. You can't simplify that down. So 12 fifths just becomes 12 fifths. Uh-oh. Look at this. We have 4 over 1 and we have 12 fifths. Are those the same? I am really hoping you are thinking no. If you're thinking no, just say no out loud. Say it right now. It's okay if you say it no. It's all right. Say it. Okay. I'm glad you said it. Glad to hear it. Okay, so now 4 over 1 is equal, it's not equal to 12 over 15. 4 over 1 is not equal to 12 over 15. So, or sorry, 12 over 5. So are they similar? No, they are not similar. So we don't even need to check that third side. Okay, we could, but we don't even need to check that third side because we have two sides that are not corresponding. Or sorry, not proportional. Because they are not proportional, I would not be able to use the side angles postulate. Okay? Or side similarity postulate. All right? All right. Awesome. That's all I have for you today. Have a good day.